Okay, we're going to pick up with example D for the chain rule. And, the question is, kind of how do we set up this structure? So I consider the order of operations. So I plug something in for x, I multiply by 4, I subtract 2. What's the next order of operation? After I take 4x minus 2, what's the next order of operation? I take the sine of it. And after I take sine, I take it to the 4th power. Yep. So your outermost structure of the problem will be negative 8u to the 4th power. Whenever you see a constant out front, obviously if it was a negative 8x, that's going to change it. What rule, if you saw a negative 8x out front, what rule would you have to use? The product rule. So, if you just kind of get rid of that negative 8 and view the problem like that, maybe that will make it a little easier for you. But what is it we're taking to the 4th power? Sine of 4x minus 2. Great. So what's the derivative of negative 8 u to the 4th? Okay, and what's the derivative of sine of 4x minus 2? Chain. Sweet. What's the outside? What's the inside? 4x minus 2. Derivative of 4x minus 2. Derivative of sine. Positive cosine. So I've got 4 cosine of 4x minus 2. So I just set up that secondary piece in order to figure out the other chain rule derivative. Okay, can I take negative 32 times 4? Negative 128. What am I cubing? What do I take to the 3rd power? So it's sine cubed of 4x minus 2. Don't write the cube after that, otherwise it looks like you're cubing 4x minus 2. But we're cubing the sine operation times cosine of 4x minus 2. So, it's a nice problem where we do the chain rule twice. Looks like a kind of a crazy derivative, but just imagine trying to do that using the formal definition of the derivative. We'd have 0 chance, okay? So let's look at these examples we've got. It says let w of x equal u of v of x, find w prime of 3. Great type of question you can see on the AP exam. It looks like w happens to be a composition function. In order to find the derivative of a composition function, we take the derivative of the inside. Which one's on the inside? V of x. So v prime of x times, so the derivative of the inside times the derivative of the outside with the inside left alone. So when it says find w prime, that's the formula for our derivative. Yeah. Chain rule. Yep. So what do I plug in? Very good. 3. I plug in 3. So we can look at the table here. Does it tell us what v prime of 3 is? Yeah, it's negative 3. Then we have u prime of, what is v of 3? V of 3 is 5. Now I want to find u prime of 5. Negative 4. So I have negative 4 times negative 3 is 12. Looks like a crazy problem, but really not that bad once you write down this first rule, right? Let's do the same thing, but let's look at it from a graphical perspective. Okay, I'm going to draw this g function in green so that we can get a really good view of it. Okay, it says let u of x be f of g of x, and let w of x be g of f of x. Find u prime of 1. I'm going to do u prime of 1 with you. You guys are going to do w prime. So what's going to be the rule for u prime if u is f of g of x? What's going to be the derivative of this? F prime of g of x, good, times g prime of x. The derivative of the inside times the derivative of the outside with the inside left alone. Okay, so what do we plug in? We're going to do u here. We're going to plug in 1. Okay. G prime of 1. What does that even mean? Slope of 1 is 3. Times f prime of g of 1. What's g of 1? 2. So I have f prime of 2 times 3. What's f prime of 2? Negative 2. You got to keep it straight. What? So I'm looking at the slope of the line at 2. So at 2, the slope, I have a rise of negative 2 and a run of 1. A rise of negative 2 and a run of 1 each time. See that? Kind of tricky, huh? You try the other one. You try w prime of negative 2. So that means you got to write a new formula. This time it's g of f of x. Yeah. F prime of negative 2, I've got 1. F of negative 2, 5. So I got to do g prime of 5. This is g 1/4. Last problem. This is the big question of the day. This is where we started. Very first day, right? How do you find an equation for a line tangent to a function at a given point? Well, what two things do we need? Point of line, slope. Well, yeah, point of line, that's easy. Slope. Oh no, I gotta multiply this out 5 times and then take the derivative, don't I? Why not? Chain rule. Isn't this just beautiful? Chain rule is so powerful. Like, it just makes our lives so easy compared to how difficult it could be. What's the outside? Inside 2x minus 3, derivative of 2x minus 3. Derivative u to the 5th. So multiplying, I got 10 times 2x minus 3 to the 4th power. Sweet, that's the derivative. Derivative tells me the slope, the instantaneous rate of change at any given point on the curve. What point on the curve do we want to evaluate the slope at? 1. I plug in 1. 2 times 1 is 2, minus 3 is to the 4th, times 10, 10. Good old slope formula, point slope formula line. 10x minus 11. Boom. This is the assignment I put up yesterday.